Hi everyone, welcome back to part 2 of numerical extension of Rutherford's model. So we made some conclusions, we got some formulas in our previous video. Now we are just solving like two questions in our today's video to test our concepts and to practice the questions. So let's begin. Now here are three formulas I want you to review. Alright, so here we go. Potential energy. We found the relation between potential energy and kinetic energy. So we got potential energy is equal to -2 of kinetic energy. So if you just know kinetic energy, just multiply it with -2 and you'll get potential energy. And total energy, so it is total energy is just negative of kinetic energy. And then here is the formula for kinetic energy. Alright, so let's try to do these questions. Okay, let me just change the pen color. Yeah, here we go. So potential energy, we have kinetic energy, this is given to us. Now for potential energy, as you can see, you just multiply it with -2. So -2 into 100 joule, it would be -200 joule. You can also use the formula. As you know, the kinetic energy is equal to Ze square k upon 2r, and for potential energy you have the formula -Ze square k upon r. So I guess this is the formula for potential energy. Alright, so you can use this formula also. Just find this and just this, as you can find this formula also, you can derive this formula also, right? This is the relation between them. This is how you solve questions based upon this concept. And now let's talk about total energy. So total energy is just negative of kinetic energy. So we had kinetic energy negative, so total energy would be -100 joule. Now let's do another question. This is a little bit twisted. Velocity of electron moving in orbit is this much. Calculate this. So now for electron, as you know, the mass of electron, it would be m of electron, it would be 1.6. No, it's not like this, it's 9.107 into 10 to the power -31 kg, and this is the velocity of electron. Okay, it is given 2.8 into 10 to the power 6 meter per second. Now to find kinetic energy, here we can use this formula, half mv square. Let's try to find kinetic energy. Half, how much m? It is 9.107. so let's take 10 or just 1 here. Okay, you can take to 3 decimal points, there is no problem. Right, so I am taking it to 1 decimal point, and -31, along with it multiplying it with 2.8 into 10 to the power 6. Alright, now here we'll be doing the square of the velocity. Do not forget this. Let's solve it. So it will be half into 91, 10 to the power 31 into 2.8. Let's remove this decimal and write it like this. Now let's just add these powers, it would be 12, and let's just cancel with 31, 10 to the power 31 here. So after cancelling, we'll get 10 to the power 19. Right, now it is 91, wait, 2 into 14 is 28, and 14 into 91, it is, where we can cancel it, so 2, 5, 2, 7, so 7 into 28 and 91, so it would be 196 into 91. There will be 10 into 10 into 5 into 10 to the power 19. It would be 1096 into 91, 10 to the power 2021 into 5. Right, let's just solve it. We'll get 3567.2 into 10 to the power -21. Right, so now this is energy, so let's write joule here. Right, we can just write it like this in the scientific notation form: 3.5672 into 10 to the power minus 18 joules. So this is the kinetic energy which we are getting. Now what we are supposed to find, we are done with kinetic energy. Now let's find total energy. So total energy is just negative of kinetic energy. It is just negative of kinetic energy. So you just put a negative sign, negative 3.56, negative 3.5672 into 10 to the power minus 18 joule. Now for potential energy, it's just negative 2 into kinetic energy. So just multiply it with negative 2. Let's try to do it. So 3.5672 into 10 to the power minus 18 joule. Let's multiply it with 2. Alright. So it would be minus 7.1344 into 10 to the power minus 18. Okay, so this is the answer for potential energy. Here we go. So we are done with this question, and let's see you in another video. Bye bye. We talk about distance of closest approach in our upcoming video.